This will be for the con exercise, dependent probability. So I don't want to confuse anyone, but for this exercise, and in this case, these will be dependent events. The formula that we'll be using for the probability of A and B both occurring is going to be the probability of A times the probability of B given A. All right, so this is basically the probability of B given that A already occurred. We don't necessarily need to write this out on each problem, okay? But generally speaking, we're going to be multiplying the probabilities, and really all you have to do is readjust the second probability based on what is given. All right, so you're going to see that in the exercise, but we're basically just multiplying probabilities. All right, in a class of 6, there are 2 students who forgot the lunch. If the teacher chooses to, what is the probability that both forgot the lunch? All right. So she's choosing 2. And what we're going to do, we're going to do them one at a time. The probability that the first student forgot, and then times the probability that the second student forgot. All right, pretty simple actually. So when she chooses the first student, what is the chances that the first student forgot the lunch? Well, that's just going to be 2 out of 6. Okay, she's choosing 1 out of the 6. And the chances that the first kid forgot, since 2 of them out of 6 forgot, it's going to be 2 out of 6. Now, once she chooses one student, there's going to be 1 out of 5 left over who forgot the lunch. Okay, so the probability of that the second student forgot, it's only going to be 1 out of 5 because she already chose 1 student here. And now there's only 1 left that forgot the lunch. And out of the 6, now there's only 5 total that's left over. Okay, so basically, it's just going to be 2 over 6 times 1 over 5. All right, once the teacher chooses the first student, there's 1 student less that forgot the lunch, and there's 1 student less in the total. All right, multiplying fractions, numerator times numerator, 2 times 1. Denominator times denominator, 6 times 5. And that's it. They don't make you reduce. They don't make you do the decimal. So it's just 2/30, 2 out of 30. All right, so in this case, basically we decrease the numerator by 1 and the denominator by 1 once we chose the first student. A goblet contains 3 red, 2 green, and 6 blue balls. If we choose a ball and then another, without putting the first one back, what's the probability that the first ball is red and the second ball is blue? All right, so the probability that the first is red and the second is blue. All right, so we are just multiplying the probabilities. What's the probability that the first one is red? Well, there's 3 red balls, and that's out of how many? 3 plus 2 plus 6. And then the probability of choosing a blue ball. Well, there's 6 blue balls, but after we chose the first red, we didn't put it back. So on the second choice, instead of having 3 red, there's only 2 red on the second choice. So it's going to be 2 plus 2 plus 6. All right, you don't have to write the denominator like that every time. You can just add them up. So the first one is 3 out of 11. All right, the total was 11. And the second one is 6 out of 10. All right, once we chose the first red ball, instead of having 3 plus 2 plus 6, it was 2 plus 2 plus 6. All right, so multiplying numerators, 3 times 6. Multiplying denominators, 11 times 10. That's it. They don't make you reduce, so it's just 18 out of 110. All right, some of these are too wordy. Captain Jessica has a ship. The ship has 2 furlongs from the dread pirate. Okay, if the ship hasn't already been hit, the captain has a probability of 2/5 of hitting. If the ship has been hit, she will always miss. If the ship hasn't been hit, the pirate has a probability of 3/8 hitting. If it has been hit, the pirate will always miss. All right. So if the captain and the pirate each shoot once and the captain shoots first, what is the probability that the captain misses and the pirate hits? All right, so if the captain shoots first, then put the probability for the captain first. All right, and we want the probability that the captain misses. So the probability that the captain misses. And for the pirate, we want the probability that the pirate hits. So that's probability of P hits, the pirate hits. All right, now these are just multiplied. Now the captain shoots first. That means the captain is not hit at first, okay, because the captain shoots first. So we want to find the probability that the captain misses. For the captain, it says if the ship has been hit, forget about that. And why is that? Because the captain shoots first. So the captain's not going to be hit. All right, so the captain hits 2 out of 5 times. So the probability that the captain hits is 2 out of 5 times. But we want the captain miss. So if she hits 2 out of 5, then the probability that the captain misses is going to be 3 out of 5. All right, so we need this. We need this right here. The probability that the captain misses is 3 out of 5. And now the probability that the pirate hits. Well, the captain misses. So if his ship hasn't already been hit, the pirate has a probability of 3/8 of hitting. So the probability that he hits is going to be 3/8. They said given if the ship hasn't already been hit, and that's true because the captain misses, the pirate hits 3 out of 8. So multiplying numerators, 3 times 3. Multiplying denominators, 5 times 8. And the answer is just 9 out of 40. Okay, you do not have to reduce. You don't have to make a decimal. In the box, 9/40. All right, in a class of 6, 4 students are secretly robots. If the teacher chooses 2, what is the probability that neither of them are robots? All right, so the probability that the first kid is not a robot, and then the probability that the second student is not a robot. All right, 4 out of 6 are robots. That means 2 out of 6 are not. So for the first choice, there's going to be a 2 out of 6 chance that the student is not a robot. And then when she chooses one, Out of the 2, there's only going to be 1 left. And out of the total of 6, there's only going to be 5 left. Numerators, 2 times 1 is 2. Denominator, 6 times 5 is 30. So that's going to be 2 out of 30. All right, last one. Again, these are kind of wordy. Captain William has a ship. The ship is, you don't need that info. Okay, so let's go down to the important stuff. If the ship hasn't been hit, the captain has a probability of 1/3 of hitting. If it has been hit, he will always miss. If the ship hasn't been hit, the pirate has a probability of 1 out of 7 of hitting. If the ship has been hit, the pirate will always miss. If the captain and pirate each shoot, the captain shoots first. What's the probability that the captain hits and the pirate misses? All right, since the captain shoots first, let's write that one first. The probability that the captain hits and then the pirate misses. All right, so the captain hits and the captain shoots first. If the ship hasn't already been hit, the captain hits 1 out of 3 times. So the probability that he hits is 1 out of 3. And the pirate misses. Remember that the captain shoots first and the captain hits. And it says if her ship has been hit, the dread pirate will always miss. So the probability that the pirate misses is guaranteed. It's a 1 or 100%. If the ship has been hit, the pirate always misses. And we said the captain hits. So 1/3 times 1 is just 1/3 or 1 out of 3. All right, so 1/3.